Okay, so question 2. What is the mechanism for transesterification? Okay, so let me write out the general scheme. But when we have a transesterification reaction, this involves the conversion of a carboxylic acid ester into a different carboxylic acid ester. Okay, so pretty much the R group on the ester changes. Okay, so now I'll draw out the mechanism. And for this mechanism, let's say that it occurs in acidic conditions. Okay, so step 1, we have our ester, which pretty much looks like a carboxylic acid group, except instead of it being at the end, it has another side group attached to the oxygen instead of hydrogen. And it has double bonded oxygen in the middle. So this is an example of an ester. And step 1 is the protonation of the carbonyl. Let me write that up here. Okay, so again, this occurs in acidic conditions. So one of the lone pairs on the oxygen will come in and attack a proton in the solution. So now we're left with our ester and the protonated alcohol group. So this is where our second ester or alcohol group comes in, and it has the desired side group that we want to use to replace the old side group, and it's in the form of an alcohol. So the second step is a nucleophilic attack. So one of the lone pairs on this alcohol comes in and attacks this carbon. And it neutralizes the positively charged oxygen. So now we have an alcohol group up here. We have our side group R1, and now we have a newly formed bond and a new side group R double prime. So this oxygen has a positive charge, but step 3 is just a proton transfer. So I'll show that this proton will be transferred to the other R group. So here is the proton transferred to the second oxygen. And now what happens next is the removal of the leaving group. So one of the lone pairs on this oxygen comes down and kicks off this entire group. Let me just write down the name of this step. Is the removal of the leaving group. So now this oxygen has a double bond and is positively charged. And you can already see that a new ester is formed with the R double prime side group. Draw the hydrogen on this end. Because the next step is the removal of that proton. I'll just say step 5 is deprotonation. And then this leaves us with a new carboxylic acid ester and H3O plus was formed in the process. And let me just box out the new ester. Okay, so this is the basic mechanism, and this is taking place under acidic conditions. So it would be a little different in basic conditions, but you should end up with pretty much the same different carboxylic acid ester. So let's see what the junior tutor said. Transesterification is a chemical reaction used for the conversion of triglycerides contained in oils into usable biodiesel in the presence of a catalyst. Yep, so this is one way people can use transesterification in the real life. The triglyceride reacts with methanol in the presence of an acid or base catalyst. This produces diglycerides and methyl ester. The diglyceride will react further to the alcohol to produce monoglycerides and a methyl ester. Continuing the process, it would have the products glycerol and a methyl ester. Okay. So they pretty much show a reaction scheme of the conversion of triglycerides Okay, so I'm just going to say that this solution is a good example of one of the applications for the transesterification reaction. Okay, so I just said that this solution is a good example of one of the applications for the transesterification reaction. However, the actual mechanism is not shown.